Okay, so we're gonna go over the actual transformations now. If you haven't watched the video that I recorded on the light board going over the different transformations and how plus and minus on the outside's up and down and plus and minus on the inside is the opposite of what you'd think in left and right. Watch that and then come back and watch this one, because I didn't want to deep dive into that while going over these. So the first thing that I want you to do when you see a graph is determine what is the parent function. Is this x squared, the absolute value of x? Is this a square root? Is this a cubed root? Is this a cubed graph? Is this a reciprocal graph? And so on and so forth. So first thing I notice of this graph is that this is x squared. This is a parabola. X squared is always our parabola. Then I realize this graph isn't at 0, 0. The vertex of your parent graphs is always at 0, 0. So since this one is not at 0, 0, it's up here at 3. That means this graph has been moved up 3. And the other thing that's different about this graph is that it's upside down. It is pointing down instead of pointing up. So this one has also been reflected. So that's what I want you to be able to do when you look at a graph, be able to say, this is a graph of a parabola, that's x squared. It's not at 0, 0, it's at 3, so it's going to be up 3. And it's not facing up, it's facing down, so it's reflected. Once you get this information from your graph, you can go and find the equations. So since I have reflected, that's a negative, and up 3 would be plus 3. That's what you need to be able to determine from your graph. So negative x squared plus 3. Look at our graph. Parent function is x squared. This is a parabola, it's x squared. It's not at 0, 0. It has been moved right 4. Since it's been moved right 4, since it's not at 0, 0, that is going to be a transformation. And when it's left and right, it goes with your parent function, like inside with x. And it's the opposite of what you would think. So just like when we did our circles, it was always x minus 4 would be our positive 4. X plus 4 would be that negative 4 because it goes into this form. Where do I want to write this? Where h and k represent our vertex. We're going to go into this specifically with quadratics more in 4.3. So stay tuned. So our graph is going to be this x minus 4 squared. And I do go into this more in the other lesson if this is still confusing. I talked just about setting up the equations, not really graphs. Okay, this is a V. This V shape represents the absolute value of x. This graph is not facing up, it's facing down, so it's reflected. And it's not at 0, 0, it's at negative 4, so it went left 4. Now that I have this information, it didn't go up and down off of it, it just went left 4, we can write our equation. So we're going to have negative absolute value of x. Since this is left, it goes inside with this, and it's opposite of what you would think. So it's the negative absolute value of x plus 4. Okay. This is also that V shape, so this is going to be the absolute value of x as our parent function. It's not facing up, it's facing down, so it's reflected. And then this graph has been moved up 1. It's not at 0, 0, it just went up 1. We should have some of these that are multiple, like left, right, up, and down, so left and up, or not just up and down, or left and up. Reflected, and up is on the outside, plus 1. That one's just positive absolute value of x plus 1. Okay, let's see what we got here. This is a parabola. It is stretched. That is our term for this. So this is a stretched parabola, but our parabola is x squared. This stretch means it's being multiplied by a number greater than 1, because it's not 1 to 1, like -1 squared is 1, 1 squared is 1. Instead of being at these 2 points right here, this 1, it's up here at this 4. So since it's at that 4 instead of the 1 to 1, our number that it's being stretched by is going to be 4. So when we write this, a stretch or a compression is multiplied by our parent function, so it's going to be 4x squared. And if it was facing down, it'd be -4x squared. But so it's not this one because it's still facing up. Okay, this one has been moved. Let's see what we got here. It's an x squared graph because it's a parabola. It's just at the top. It's not at 0, 0. It's at 7, so this graph has been moved up 7. If I check for a stretch, it's 1 to 1 right there. So like if I go over 1 and up 1, it's going to line up there. So it's not stretched. This one is just up 7. Not upside down. Be sure you're looking for those negatives when you look at these, because I almost click it every time. Oh, this is a V, so this is our absolute value graph. It's at 0, 0, so it's not up, down, left, or right. This one has been stretched, so instead of being at -1, -1, and 1, 1, it's at, looks like 8. So it's reflected because it's upside down. And if you can't tell what the specific number is, know that this is stretched. So it has to be multiplied by a number greater than 1. So when we go and look at it, I think they don't, like 8's on all of this. So if you didn't realize that it was 8, you can just go find the one that's -8 times the absolute value of x. And the negative comes from the reflect, and the stretch is the 8. Because you don't put -8 as your stretch, because that would reverse that negative flip. Okay. This is the absolute value of x. It's 1 to 1, it's going up, but it's not at 0, 0, it's at 4, so this graph went up 4. So we're going to have the absolute value of x, up and downs on the outside, plus 4. Write the function whose graph is the graph of y equals the absolute value of x shifted to the left 5 units. So left is the opposite of what you would think. It's plus 5 because if I solved it for x, I'd end up with -5. Write the function whose graph is the graph of y equals x squared, but is shifted up 3 units. So up and down go on the outside. So we're going to have x squared plus 3. Write the function function whose graph is the graph of y equals x cubed, but is vertically stretched by a factor of 7. Stretched is when we multiply, so it's going to be 7 times x cubed. So 7x cubed. On these, you have to be really sure to pay attention to the order of which they do these, because this reflection is going to do different things in different spaces. Like if we reflected first, it would change this order of the graph. So first we have our square root of x. Then they say down 4 units, so that's going to be down 4 units. This is our first one. When I reflect this about the x-axis, I multiply everything by the negative because that's the second step. So when we do this, it's going to change it to negative square root of x, and then a negative times a negative there makes it positive 4. So that's after 2. And then 3, when you reflect about the y-axis, you put a negative inside with your x. I'll just write it again. So this is our final one. So negative square root of x with a negative, click out of that, plus 4. Remember just to do these in order. So this one's different. It's the square root of x. They want us to reflect about the x-axis first, so it's going to be. Then they want us to shift down 9 units, so it'd be negative square root of x, subtract 9, and then they want us to shift right 3 units. And remember it's opposite, so right is negative, because if we solve for it, it would change that. Negative square root of x minus 3, click out of that, subtract 9. I know there's a problem like those steps on the test. Starting with the graph of a basic function, graph the following function using the techniques of shifting, compressing, find the domain and range of the function. Okay. When you graph these, it does not matter where you click it because it's going to put it at 0, 0. So we are using x squared, right? So if I went to put this at positive 4, it's going to put it at 0, 0. So you just click it and get your graph on there. And you have to use this shifts and stretches. So ours was plus 4. So our vertical shift, I might have to start over, is going to go to positive 4. 2, 3, 4. Check answer. Our domain is x. Ooh. So on this graph, our domain is going to go from negative infinity to infinity. And then our range is y. I guess I can type that in first. I'm gonna sneeze. Our range is y. In our graph here, when you do range, you go bottom to top. So going from the bottom, you get to the graph at positive 4. And since it's at positive 4 and you can equal it there, it gets a bracket, and then it goes off the top of the graph to infinity. So bracket 4 to infinity. Next. Graph the following. We have the square root of x subtract 6. That subtract 6 is with our x, so this is going to be our square root graph, and then the subtract 6 means right because it's the opposite. So right 6. This one went left, this one went up, this one went right, and that one went down. Our domain, so looking at our graph, left to right, our x values start at positive 6, so it's going to be bracket 6 to infinity. And then our range values, bottom to top, from the bottom we don't start until we get to 0 and go to infinity. I hope this is making sense. I hope the video before this helps as well. Okay. The last one of these, I do believe. The big thing you have to pay attention to on this one is that this is stretched by 12, and they have these different scales. So like this one's 40, 40, 1, and 1. So the ones that have 1 are not going to be options. So we're looking at the 40. If I have the square root of 4, let's do the square root of 4. So let's make us a little table then. And we'll do 1 and 4. Because there's a square root of 4. That's why I'm using 4. Because if I do the square root of 4, I get 2. And then this is our function. And this will give us our y value. So 12 times the square root of 1 would be 12 times 1, which is 12. So at 1, I should have the value 12. So is that going to be here or here? And then if I have 12 square root of 4, that's going to be 12 times 2. So 12 times 2 is 24, which is going to be a little over halfway to 40. So B is going to be our answer on this one. Be sure that you pay attention to your scales first off. And then when you plug in a number to the square root function, be sure it has a square root. You don't have to do that, but if you pick 3, you're going to get a crazy decimal, but you can use that decimal to determine where you'd be at. Let me get rid of some of this extra. Okay, so domain and range, we're looking at where this graph starts. And if we look right here, they only give us that first quadrant because it starts at 0 and goes off of it on both of them. So from bottom to top, we start at 0. From left to right, we start at 0. Because this is a square root function that's been stretched. My head is hurting today. Infinity. Okay, so that is all for 4.3, not 4.3, 3.5. And I'm going to start 4.3 next.